Hi and welcome Year 10 students. Today we're going to carry on looking at some of the topics that some of you found more difficult through the exams and tests. And the one I've chosen today is differentiation and tangents, and working out the tangent at a point on the curve. So I've sent you some work from, I think it's exercise, maybe it's 10.6 I think, I can't remember. It'll be on the sheet that the teacher has, and I thought I would do some of the questions with you. So obviously the ones that we do in this video together you don't have to repeat, okay, that would be silly. So work with me. I'll try and go at a reasonable pace so that it's not too fast for you. So if you have your exercise books ready and a pen ready, we can work through these together. Okay, so let's look at this number 2. We've got a curve. What do we know about this curve? Well, it passes through this point 1, 1, so it goes through that point. And this is the equation of the curve, y equals 3x to the 4 minus 3x squared plus 1. And we've got to find the equation of the tangent. Now, let's just refresh our memory. Let's say we've got and this is definitely not the equation that has been drawn, okay? I'm just giving you an example. Let's say that this is 1, 1 here, and we wanted to find the equation of the tangent at that point. What we would do is get our ruler and try and draw a line that fitted the gradient at that point in time. But there's another way we can do this without drawing, and that's by differentiation. So what we do is we can differentiate this here. So we write dy dx equals, and we take the 4 that is the index of the x, and we multiply it by the coefficient, so that becomes 4 times 3, which is 12. Then we drop the power of x down by 1, so it would be x to the power of 3. Now we're going to do the same kind of thing here. So we've got that 2 times the minus 3, which is negative 6. The x drops down from 2 to 1. You don't need to put the 1, right, because x just by itself is x to the power of 1. And anything without an x like this just drops out. So what we have here is our gradient function. Okay, that's a gradient function, which what we can now do is we can put this value of x in, and that will tell us the gradient at point 1, 1. When x equals 1, dy dx, or the gradient function, what does that equal? Well, it will be 12 times 1 cubed, which is 12. So 12 times 1 cubed. Take away 6 times 1, and we know that that is 6. So we know one thing about the gradient here. This gradient, and again, I have not drawn the graph because the graph here is not a cubic, right? It's what is it called? Quartic or something. Okay, that's not what we've got there. So, but the gradient that we have worked out is 6. So every time we go across one, we go up 6. And we have a point on the curve. So when we have a point on the curve, we can use our line function, our line equation, and we know that the line equation is y minus y1 equals m into x minus x1. Okay, so let's put in those values. Y, our y1 is this bit here, so that would be minus 1 equals m. We found that in the previous part of the question. That's our gradient, into x minus 1, and then we can simply work out what we have by expanding. So I'd get y minus 1 equals 6x minus 6, and rearrange, and I get y equals 6x, and that minus 1 I add to both sides, so it becomes minus 5, and that would be the equation of my tangent at the point A. Okay, well that's the first one. Let us try number 3. So what do we have with number 3? Well, again, we have a curve, and we know that it passes through a point, and we've got to find the equation of the tangent at that point. Okay, well, let's do that. Shouldn't be too hard. We'll first of all find the gradient function. So I want you to have a quick think about that. We're looking at this. What's the gradient function going to be? Write it down now. I'll give you 15 seconds to do that. Wow, that'll do. Okay, so that 4x becomes 4, because the power of the x there is 1. 1 times 4 is 4. And then x to the power of 1 drops to x to the power of 0, which is just 1. Okay? The next one becomes 2 times minus 2 is 4. And the x drops down to the power of 1. So I'll just write minus 4x. And the next one, it'll be 3 times negative 2, which is negative 6. And then the x drops down to 2. So that's our gradient function. And at x equals minus 1, what is the gradient function going to give us? Well, dy dx will be equal to 4 minus 4 times minus 1 minus 6 times minus 1 all squared. And what is that? 4 plus 4, because the minus 4 times the minus 1 is positive 4, so that's 8. Take away 6, which is equal to 2. So this is our gradient at that point. And once again, we're going to use the y minus y1. So this is the formula we use to find the equation of a straight line when we have a point. So we've got a point here, and a gradient, which we just found here. Okay, so it'll be m into x minus x1. See if you can do this and faster than I can. I'll just do it slowly. That's y minus minus 4. The gradient is 2. X minus, and then x1 is minus 1, so it's x minus minus 1. I'm going to simplify in my next line. I get 2x. Now minus minus 1 is positive 1, so that's plus 2. I get y is equal to 2x minus 2. And that should be the equation of my straight line there. Right, well, let's go on to number 4. I'm not doing part B, I just want to focus on the tangent stuff. Okay, so we've got another curve here. It's just a cubic this time, and it intersects the x-axis at C. Okay, so where does it intersect the x-axis? Well, we know it intersects x-axis when y equals 0, right? Because, okay, here's our x-axis. What do we know about y? Anywhere along here, y is 0. So let's find the coordinates. We're going to take this here, y equals x cubed plus 8. We're going to make y 0. So we're going to find out the value of x. And then I would say x cubed equals negative 8. And that means we would take the cube root of negative 8. And that is going to be, in this case, negative 2. So the coordinates of the x-intercept are minus 2, 0. That's our x-intercept. Okay, now the tangent to the curve at C intersects the y-axis at D. Okay, so let's find the gradient function now. So dy dx. See if you can do that for this quickly. Should be 3 times 1, which is 3. X, drop the power down to 2, and then the 8 drops out. And at x equals minus 2, gradient equals 3 times negative 2 squared. Negative 2 squared is 4. 3 times 4 is 12. So the gradient will be 12. Now, we want to find the equation of the line. We're going to use the y minus y1 again. So y minus y1 equals m into x minus x1. And here we know the y value is 0. So y minus 0 equals m, we found to be 12. X minus, and this is our x value here, minus 2. And so we get y is equal to 12x plus 24. And that is our equation. Now, the last part is we have to find the distance CD. So where does this tangent intersect the y-axis? Okay, where does it intersect the y-axis? Well, at the y-intercept, right? Okay, so that's at 24. Line intersects the y-axis at 0, 24. And now we've got to find the distance between D, this is D here, and this is C here. So we're going to use Pythagoras at this point. So how do we do that? Well, we're going to do the square root of y1 minus y2 all squared plus x1 minus x2 all squared. Remember this formula. If you don't, you need to revise it because we've done it enough times. Okay, so I'm going to go square root, it's going to be a bit messy, 24 minus, this is my y values, minus 0, isn't it? That's going to be squared, plus, and then I'll go 0 minus 2 squared. And, oh, we plug this into our calculator. What is that? 24 squared plus 4 equals square root answer. I'm getting 24. You can just check this on a calculator. I'm getting 24.1 as my distance there. Okay. I'm just aware that the time in the lesson is slipping away and I want you to have some practice. I might just do one more. I won't do 5. I will quickly show you how to do this type here, number 9. Okay, so we've got a tangent to this curve at different points. So first of all, we want to get our gradient function. So for the gradient function, I'm going to have minus 3 minus 2x. And we've got two different gradients at 2 different points. Okay, so we want to find the two tangents. At x equals 1, dy dx equals, and we just chuck it in, minus 3 minus 2, which is negative 5. At x equals negative 3, dy dx equals, well, minus 3 minus 2 times minus 3, which is positive 6. So I think should be positive 3. I think that's right. Hopefully I'm not stuffing up here. Now I'm just going to look at the tangent 1. So we're going to do this one in the purple. Y minus minus 2 equals, what was our gradient for that one? Minus 5 into x minus, where's that? Oh, well, you Larry. No, I want that's my y value. I want my x value. Sorry, guys. Okay, we simplify that, and that gives us negative 5x plus 5, and we take everything across. Okay, and we get plus 3. So that's one tangent. See, what we're trying to do is find where they meet. So we have to figure out what each tangent is first. So now let's go ahead with the second tangent, and that's the one here. Okay, so this is tangent 1. Let's do tangent 2. Y minus 2 equals, the gradient in the second tangent was 3, into x minus 3. And so we get y minus 2 equals 3x, and that minus 3 is like a positive 3, isn't it? So we'll get plus 9 here, and then we should get y equals 3x plus 11 when we simplify. So this is tangent 2. Alright, now, where do they meet? How would we find out where these two tangents meet? Well, we are simply going to make this equal to this, and that will give us the x value. So we go minus 5x plus 3 equals 3x plus 11. Bring the x's across to one side and the y's across to the other. So I could get negative 8x if I subtracted 3x from both sides. And if I subtract 3 from both sides, I get 8. So I brought this across here and this across here. Okay, so hopefully it makes sense. Whoops. And then x must be equal to -1. That is where they meet. And therefore, I need to find the y coordinate. Y equals, and I can just chuck it in here, can't I? Right? 3 times -1 is -3. Plus 11 is 8. So they meet at -1, 8. That would be point P. That's where those two tangents meet. Well, I hope this has given you a good introduction and a refresher on how to do this. I know some of you have really struggled with this. So get on with as much as you can do with the rest of the lesson now. And keep sending those questions in. It's good to hear from some of you. I've had some questions from you, Ishan and Josiah, so I really appreciate that. Make sure if you do have questions, you flick them through. I will answer them as soon as I can. Alright guys, God bless, take care.